Hello, everybody. My name is Catalina Naranjo, and today I want to talk to you about charts, and not just pretty charts, but instead visualizations that are clean, are honest, tell a story, and why not help us to see the world in a different way. Today we're going to cover different key concepts for data visualization. We're going to talk about politics, about law, and a little bit about the magic that we can achieve with Altair in Python. Let's start with this chart. This one was a pretty viral one in 2024, back when the Trump's campaign was sending some message to all those potential voters. And we're going to break this down in a little bit. But let's start with the basics of data visualization. We always expect that our visuals are going to be clean, obviously not this time. And keep in mind that this is something that was shared by a political leader. So when we see these kind of charts coming from an official source, there's no reason why we would doubt the information that we're looking at, right? It seems official, it seems like it's true. We have bars, we have numbers, we have annotations, so why would we doubt that it's true? But this is something that you should always consider, not only when you are creating a chart, but also when you're looking at any visualization. What I'm looking at here, is this true or not? There's a lot going on in here, so we're going to break this down a little bit. Let's start first with something that is called chart junk, and that's what I'm telling you here, chart junk alert. And if you haven't heard this term, no worries, because I'm going to explain it further in a couple slides. But we can translate this as visual chaos. There's so much going on in here that is distracting from the main message from the chart, right? We see poorly chosen colors, we see lots of arrows, lots of text. So that's what I'm calling visual chaos here. There's another layer to this, and those are some of the things that we have in this chart that whoever created it is claiming for you to listen and for you to hear or see a narrative here. So let's break this down, because it's telling us illegal immigration into the US. Nothing like this has ever happened to our country before. You know, that's quite a statement, right? So we're assuming that what we're looking at here in those bars are going to be number of people who illegally immigrated into the US. They're telling us a world record. I mean, our global context today with wars, political instability, people migrating from any country that you can think of. Can we seriously say from this chart that this is a world record? That's something that you should think about. There's another sentence here that is really important right at the bottom. And whoever made this chart is telling us, when Trump left office, that was the world record for the lowest illegal immigration. So we're saying that during Biden's term, we saw the highest number of illegal immigration, but also before Trump left office, that was the lowest record in history. Again, we don't know if that's true from this chart. And keep in mind that we only have 12 years in here. So maybe that's a huge statement for us to think about. And finally, and not less important, they are telling us that this chart is based on US Border Patrol data, which again sounds official. You could believe that this is true because, you know, it's an important agency in the US, so you might think about it. But there's a lot of context missing here. So we're going to review one by one what are the different steps that we want to take to make this chart better, because there are a lot of things that are wrong here. The first one is the data. So this would be the worst case scenario, honestly. The data is not accurate, and this is because data definitions matter, and that's something that always keep in mind when you create something. Definitions matters. And in this case, it matters a lot. But it turns out that in 2020, there was a change in the definition of the data that you just looked at. Before, we were talking about something that is called Title VIII apprehensions. Apprehensions means basically the number of people that were caught trying to transfer a border in the US. They were caught and they were processed. We're talking about immigration law. Before 2020, in March, that was the definition. But since the pandemic, the data definition changed. Now it's not only apprehensions, they are also including something that is called Title 42 expulsions and inadmissibles. So by definition, the data changed. And if you remember that huge spike in Biden's term, that's going to contain all of those inadmissible, right? So again, worst case scenario because the data is not correct. The data source, they are claiming that they are using US Border Patrol data, but that's not true. They are using data from a different agency that is not comparing apples to apples. And finally, but equally important, the visual choice for that chart, as I mentioned, are not the best. The visual encodings are not right, the colors are not right, the title and the annotations are not right. So I think we can do better, and for that, we're going to talk about two main concepts, visual encodings and chart junk, and then we are going to move on to what we can do with Altair and why Altair can help us to create a narrative and craft a story that is going to be more impactful and honest. So let's go from misleading to meaningful visuals, talking about visual encodings first. Visual encoding sounds like a fancy term, but the truth is that all of you here, if you have ever done a chart, you have done and you have used visual encodings. It's just a term for the language of data visualization. And a visual encoding is something that is going to encode data. That something could be size, could be color, length, angles. Pretty much if you think of any chart type, you're going to discover that there is a visual encoding behind that. So again, all of you know visual encodings, but maybe you haven't thought about it that way and how to structure properly those visual encodings. Let's take a couple examples. Length. So when you see a bar chart, length is the visual encoding here. And it's very easy for the human eye to understand length. We can easily take a look at one bar next to each other and we can say very easily, this is half of last period or this is double last period. It's really easy. Let's take another example, another visual encoding, which would be angles. Angles from the infamous pie chart. And anybody in the data visualization world will tell you that they don't like, I don't like personally, pie charts. But not only because they are unattractive, which I think they are, most importantly is because for the human eye, it's really difficult to read angles. And especially when you have so many categories that you create something that is really cluttered, it's going to be really difficult to understand. So bottom line here is when you are going to create a chart, think of what would be the best visual encoding for that data type. There's not an answer that will be enough or that would be correct for any data. Just be mindful of what you're using here because that's going to be the start of a great story that you can build. Now moving on to chart junk. This is a term that was coined by Edward Tufte, who is known as one of the founding people in the data visualization world. And he has some specific opinions about any element that is not encoding data. Keep that word in mind because I'm going to mention it many times during this talk, encoding. What Tufte says is, above all, show the data. Any visual element that is not encoding data is going to be something that needs to be removed. Anything that it's not coming from a variable, anything that is not encoding something is going to be junk, and you need to remove it. So that's something that I agree with for the most part, and depending on the audience. Let's take a look at this chart with the cute little monster there. And what we're seeing here is the same data. This is an example, very famous example from chart junk, and it comes from data from campaign expenditures from House and Senate in the US during 1972 through 1982, so 10 years. You can see the bar chart, it's an enormous increase in expenditures. But what if whoever made this chart was going to use it to put it in a front page of a newspaper? Which one do you think would be more impactful? The monster, right? What they're using there is the teeth instead of bars. It's fun, but all around that, it's chart junk. So here is when we have to make a trade-off. It's like we need to create clean visuals, but also we can play around a little bit with chart junk when it's purposefully used. That is going to be the most important thing. There are a couple scenarios when we can use chart junk. For instance, when you want to reinforce your meaning. So basically, you want to give visual cues to your audience so that they can understand better. You can make small and insightful annotations. You can use visual elements that are not going to encode data as long as this is done with purpose and as long as what you are showing is going to tell a story. Let's move on to Altair and why I think that it's a great library for data visualization. Because after we have learned what visual encoding means, then this is going to be really intuitive for you when you look at this. First of all, Altair is a library that is built on top of Vega Lite, which is specific graphic grammar. But you're using Python to create your charts. So again, the key word here is encode. You just tell Altair what you want to encode, and it's going to be really easy as long as you understand visual encodings. That's why I like it so much, because it actually forces you to think about your design. It's not about how you want to do the chart, it's about what you want to show. And I think that shifting that mindset is really valuable, because when you're working with libraries like Seaborn, for instance, for anybody in the data space, you will know Seaborn, and it's a very good library for other things, maybe not so much for storytelling. So that's what makes so special Altair here. There are a couple features that I also really like, and is how you can easily show what your variable type is without doing any transformation, and you just tell Altair how you want it to interpret. Maybe you have numbers, but you want it to be interpreted not as a number, but as a category. You don't need to go and change the data type. You don't need to go to pandas and do some transformation, even aggregations you can do with Altair. But the fact is that it's very easy to do this with those simple commands that we have here, starting with the method encode. For instance, in this example, I'm saying I'm going to encode age, which is a quantitative variable in the axis X, and then income is going to go in the Y-axis. I'm telling this, it's going to create a bar chart with that mark bar statement, and then I'm going to color code gender. So literally what I'm doing is thinking about the visual encoding that I'm going to use for each one of my variables. And that's what makes it so easy to create visuals that from the start are going to be very clean, very intuitive. I'm not going to go very deep in here about the comparisons, and again, it's a matter of preference. There's not a best library for everything. The best library is going to be the best one for the objective that you're trying to achieve. If you're going for a narrative, if you're going for data storytelling, I could tell you that Altair works better than Plotly or Seaborn. If you're looking for interactivity, maybe go with Plotly. Altair does have some really cool features for interactivity, but if you're creating a data app or something like that on top of Streamlit or Dash, maybe you could go with Plotly. And the syntax would be like the main difference here, because it's declarative. Again, you're telling what you want to do instead of how you want to do. You don't need to spend a lot of time giving instructions for how you want the access to work, how you want the properties of the chart to work, because this is going to be fairly easy. And in terms of learning curve, I would say that it's moderate for Altair. It's medium, basically. Plotly, you can create basic charts very easily, but then when you want to customize, it gets a little bit messy. And Seaborn is just not the tool for data storytelling. That would be my advice. So now that we have covered the theory, let's go to practice. I told you that we could do better. The same visualization, I'm going to use the same data that Trump used, and we're going to create a narrative here. So let's go to step 1, which would be encoding the Title 8 apprehensions. Remember, that's the number of people that try to cross a border, according to Trump's data. Very clean, very standard chart, soft grid lines, neutral color, already including some properties like title for the axis and well, for the chart. This is going to be a very clean visual. And that's what I'm telling you, like since the beginning, you could create something that is visually appealing, something that can work, and I didn't take many steps in here. Let's go to step 2, where what I want to do is encode presidential terms. And I'm also using color encoding. In this case, the blue and red are intentional because one represents Democrats and the other represents Republicans, right? We all know that. So I'm giving context here. I'm still not adding chart junk. Step 3 would be to encode another thing, which is going to be the change in presidential terms. This is going to be a visual aid for anybody who's looking at this chart, and they can easily compare one bar from one presidential term to another. Again, it's a help for the audience so that they can understand better, that they can provide context. Now we're going to move to step 4, which is going to be a little bit of breaking the rules. Because here I will add some chart junk. That's what I told you. Sometimes a little bit of chart junk never hurt nobody. And in this case, I'm going to make some specific annotations here. One would be, I'm going to highlight the moment when the data definition changed, remember, in March 2020. And the other one is going to be an annotation for telling everybody, okay, so this was the average before the change in the data definition, so that anybody who's looking at that can make their own judgment. And finally, look what a simple line and a title that is going to tell a narrative, how this, with the same data that you just observed at the beginning, is going to tell a very different story. This is a tale of 2 metrics since 2020. And that cool feature that you can create a rule, that's something that very easily, if you live in the corporate world and you have done any PowerPoint presentation, like you would add this, like some rectangle with some transparency, like this is something that you can actually encode, and you can actually tell Altair to do above or beyond a threshold. So I think it's a really cool feature. So again, I'm telling a different story with Trump's data. But what if I move on and I tell you a different story? What if I use the correct data set, which is going to include only apprehensions and not expulsions or inadmissibles? And what if I expand a little bit the timeline? Not only 12 years, I went back to 2000. I added 12 more years. So in this case, remember that statement about the nation has never seen something like that. This is a world record. Look at my line. What was the max number of apprehensions back there when Bill Clinton was in the presidency? Now that world record doesn't seem so impressive anymore, right? And again, this is how a simple line and a couple annotations can change your story from one thing to another. It's a very dramatic shift. It's not only about, it's more pretty, you know? It is, but the fact is that we're telling a different story here. So now let's move on to the next section of this talk. And I think that in Enrico's talk, I got inspired by a couple of things that he said. And it's people goes before technology, and people goes before data. But what's interesting is that most of the time, data is about people. And what's more human-like than love and relationships? I wanted to bring something fun, a fun data set to play with, so that I can show you that you don't always need to have the most spectacular data set. You don't need something that goes 60 years before. You don't need high granularity. You don't need a lot of things that we always expect when we're creating a chart. Sometimes the data is not as fun as we would like to, but we can still create some fun stories around that. The data set that I'm using is a survey from the US YouGov agency, and they surveyed a little bit more than 1,000 adults in the US, and they asked them different questions about their relationships. You know, the good, the bad, the different steps that we take in relationships. And pretty much every data point is going to be something for yes, no, or not sure. For me, that is a pretty boring data set just because I don't have so many dimensions as I would like to. What's interesting is that the data is split by gender, by political party, by income level, so that we can start to create a narrative here. Let's take a look at this chart. This is a scatter plot built in Plotly, but I'm using it to show something that I call the love timeline. This is what I assume would be the love timeline when we start dating somebody, you know? First you go on a date, then you go and, be in love. Then you tell each other that you are in love with the other person. Then you live with your partner, then you get engaged, and then you go and get married. That's how I think about love. It would be interesting to see that there are many different views for this. And what we have here is for those different steps, we're looking at different age categories. So the younger generation would be the first one from 18 to 19 years, and then the elder generation would be above 65 years. What we see here is that marriage isn't what it used to be. If we compare an 85 or 90% of people above 65 years old that have been married against younger people that it's only at 20%, you could tell me, yes, but they're younger. I mean, it's normal that they haven't been married. That's something that I agree with. But if you look at this vertically and you look at the different percentages here, this is telling us a different story. This is telling us that people don't want to get married anymore as before. I don't know why, but that's a fact. Second insight that we can get from this chart is about cohabitation, or as I call it, living together before ever after. In this case, it seems like living with your romantic partner has become a more important step for people rather than marriage. Sometimes marriage is not the end goal, but the end goal is going to be cohabitate with another person or your significant one. And this tells us a lot, because if you look at the percentage for the older generation, you will see that it's not so common for there. Before, it was like you get engaged and you get married. It's not like this is a test drive or something. No, for us, it seems like for younger generations, it's pretty different. Now, if we go to the third insight for this chart is how the I love you goes and how the pattern is different from many generations. So, for instance, for the younger generation, when they say I love you and they receive the I love you, it seems like it's very standard, like those percentages are very similar. But if you go to other generations, it seems like we have heard it more than we have said it. Again, we cannot draw strong conclusions from this yet because we would need more context, but I think it's interesting to think that maybe younger generations are just more open to be, sensible and vulnerable with their partners to say I love you the same that they hear it. Let's go to the next chart, which is just a dumbbell chart made in Altair. I'm using the heart emoji just as the marker instead of a boring point. We're talking about love. What's interesting here when we look at love and specifically romantic challenges is that women report to have gone through these romantic challenges, like being cheated on, like broken up with somebody. Those sad experiences, it seems like women report that they have been there more than men. I don't know if this is true. Maybe we could think that men are more reserved with the way that they feel, or maybe they just live heartbreak in a different way than women. I think it's interesting, but there are a couple patterns here that you can add on top of this. First, pretty much is the same percentage for cheated on someone. So that's not a gender story, cheating. And also, if you look at the last one, attended couples counseling. So regardless of gender, that's not a very common action that anybody's going to take when their marriage or their relationship is in trouble. Now we have from Plotly a polar bar chart, which is going to show us how comfortable or how open are people to date people that are different from them. Different in terms of religion, of income, of gender, of many different categories. And it shows that there are some things that people feel comfortable with. People feel comfortable dating somebody from another religion, dating somebody from, with a big age gap. But the things that people are less open to when they're dating somebody are going to be income and especially political party. So in this case in the US, it would be very unlikely that a Democrat would be dating a Republican. Again, makes sense, and we live in a very polarized world. And finally, I wanted to add this clean visual. This is just a regular bar chart. Look at this, I'm only using one color. Please don't use different colors when you're using bar charts unless they are encoding something. Very clean visual to show you a little bit about uncertainty. I told you at the beginning of this section that the possible answers for the respondents of the survey was yes, no, or not sure. And I think this is really interesting because I am sure if I lived with someone, I feel sure if I was in love with somebody, but it seems like people hesitate. And I think it's interesting because it's like love is not something that you can actually account for, and there are some blurred lines for people that respond to this. Was I really in love with this person? Did we break up if we weren't official? And I think that uncertainty, again, is something that makes us human, and sometimes the best answer is not a binary one, but just like it's complicated. It's a complicated relationship. So with all of this, I just want to close this talk with a final message. Always keep in mind those visual encodings. That's going to be the main thing that you need to create a great story. There are some, specific visual elements that are going to make your story more impactful. And that's the end goal of all of this, not to just make pretty charts, but make them honest, make that, memorable for your audience, that it resonates with them. And please, no more exploding 3D pie charts. We'll hate it. So thank you everybody for joining me today. If you ever want to connect, talk about data visualization, reach out. Thank you everybody.